right, welcome to the Engineer's Guide to Sustainable IT. Well, today I'm going to unfortunately talk about these kind of things: floods and forest fires. And it's not something I really would want to be talking about, or landscapes I would want to be in. I'd rather be in a landscape like this. Lots of green, lots of nature, fresh air. Because the previous landscapes, well, are the effect of extreme weather due to climate change. My name is Mark van der Walle. I'm a lead software architect at Society. Do most of my work in Java, preferably cloud native, with a touch of observability. And what if we wanted to change what we do in IT with the climate, our impact on the world? So what could we do? And there are some obvious answers. And most of the times I hear people say, just go to the cloud, right? Because the cloud is green, the cloud is clean. It's not my problem anymore. Or if you're able to go to the cloud, you should just go serverless, because then you use way more, or way less, I mean. So you're way more sustainable. And that's all true. But the problem is a bit bigger than that. Because even if you're using the cloud, you're still using energy, electricity. And a fact is that still 60 to 70%, depending on the time of day, depending on where you are, is still dirty energy. So still being generated by fossil fuels. And the problem is also roughly 40% of our carbon emissions in the world are coming from electricity or the energy supply. So what can we do? What can we do better next to going to the cloud? Because that is indeed a approach, but it's not the end approach. Well, cleaner energy. I mean, that's quite obvious. We need to get rid of all those fossil fuels, coal, oil, gases, depending on the type of gas. And we need to do something with that, but that's not something all of us can do. I mean, we only have so much influence on what we do. And this needs to be probably done by larger organizations and governments. What I'm going to talk about today mostly has to do with this: waste. Because it's an unfortunate fact that we as IT professionals tend to build quite inefficient software. And we don't do that on purpose. We do that, due to all kinds of facts, due to time pressure, because it's convenient, it's cheaper, or that we just don't know any better. Because, we just build software, it runs, hey, next feature, next story. And so then we toss a ton of hardware at it. And that hardware is constantly running. Look at all lights, infrastructure for Wi-Fi, but also the big boxes in the data center. And are we using them? Or are they just spinning there all the time without doing any work? It has been mentioned by quite a lot of people across history. So by Peter Drucker, Lord Kelvin, who was actually where the Kelvin measure of temperature came from, and also Edward Deming. So it basically comes to this: you need to measure something before you can change it. And that is what brings me to the main subject of this talk: observability. You need to be able to see what's happening before you can change it. You need to be able to extract the information from it before you can do something with it. And this is what ChatGPT says about observability, because indeed these days you have to have something like that in your talks, right? So it's the ability to understand and invert an internal state of a system and its behavior by measures and analyze that and then use that to diagnose problems. But diagnosing problems is not the only thing you can do with it. You can look at inefficiencies and you can look at sustainability. So observability, just quickly to recap. It's based on 3 pillars. The first one is logs. So your applications logs things, your infrastructure logs things, well, anything can generate a log. Usually you have metrics, think about CPU, memory usage, disk I/O, network, but also connections, incoming requests, etc. And then you have traces, preferably distributed, where you can trace everything that's happening across your bigger landscape. So that's the 3 pillars of observability. And then we get into something funny. Because whenever I, at a client or at a project, introduce observability, and even in the first stages of that adoption, there is something happening. And people think, hey, what is going on? We see all these problems. We see all these issues. What is going on? Well, nothing is going on. There's nothing different between yesterday and today. But what observability tends to do is make things really obvious. Like there is 5% error rate. Well, yesterday we just had a bunch of logs, we didn't do anything with it. But today we know, and we can act upon it. And that's the same for applying this for observability. You just need to make it blatantly obvious up to the point where you probably are almost ashamed not to do something about it. So what does that look like? That looks like something, well, like this. Utilization. So I talked about hardware. If your utilization looks something like that on the left most of the time, then you're not using your infrastructure as much as you could. So you either have the ability to scale it down, reduce costs, and reduce carbon emissions by using less energy. If your utilization would look most of the time somewhere on the right, so high, and also, well, constantly very high, you might think, okay, we're utilizing our infrastructure very well, so we can't do anything there. Well, then you need to look at, are we actually being efficient? Are we actually doing it in the right way? So what do you need to look at then? So, and I think the next one, Java developers especially, who do something with persistence, know quite well. It's the N+1 problem. These are very easy to cause. Like you have an entity, and it has a relation, and you want to get something from those, and suddenly you create this N+1 problem. And at first it's fine, because your database is small, and it grows over time, and things get slower, and it's fairly inefficient, because query goes to the database, returns result, query goes to the database, returns result. And what you see in the picture is that each of those queries is fairly fast, in the microseconds, but it sums up to 22 seconds. So it's user experience, it costs resources, and thus more emissions. So this is something we can easily fix. We can improve on this, and then you still need to measure if it's then better. But making it this obvious, like, okay, we're doing quite a lot of queries to just fulfill this request. Oh, what can we do on the back end? next to obviously our persistence. Well, do we really need to do all these requests to that other system? Can we cache something? Can we combine things? And again, it is about making this obvious. It is about using the data that you have, looking at it, and see where you can improve. And I'm not telling you what you should do, because that really depends on your domain, on your business constraints, on all kinds of other things. So I'm not telling you that you should cache more. Well, I can say you should cache more, because probably that works for you. But you need to look at your own unique situation. But first, make it visible. Now, front end, browser, or mobile, because if my mobile phone is working hard, it uses energy, I have to charge it faster, which, again, might be due to extra carbon emissions. I don't know where the electricity is coming from if I plug it in here. So make it visible. And measurement, what I'm now talking about, is only the tip of the iceberg. There is this Green Software Foundation that has 6 bullet points, and they talk about high over-measurements, like the Scope 1, Scope 2, and the Scope 3 emissions. But if you have the ability to improve your application landscape by just making things visible, making it really obvious, you can do something about that Scope 1 and Scope 2 emissions. And hopefully your suppliers do also something about it, and then you can report on better Scope 3 emissions. So this is not a silver bullet. Making it visible, it's just one part of a whole. But it is something that we need to talk about. And it is something that we can do tomorrow. And it is something I really urge you to work with. I really urge you to take a look at your landscape, and if not for the sake of sustainability, then perhaps for the sake of cost savings, or for the sake of user experience, because they tend to go hand in hand. If you start making improvements on your infrastructure, on your applications, and on whatever you need to do with that. And hopefully, we can ensure that we are walking more in these kind of landscapes and keep that for, let's say, the next 50, 100, 1,000 years, our soil, our nature, not only for us, but for our children and our children's children. So thank you. That was what I wanted to talk about, what I wanted to draw your attention towards. You can reach me by email. You can reach me via LinkedIn. And please rate my session. And hopefully, I meet you in the hallway and we can have a quick chat about what you can do with this. So, thank you for your attention. And see you around and have a great conference.